In this video, we're going to try and prove the absolute convergence theorem. So we've used this in the past, where it's saying that if you have an alternating series, say, what you should do is you should look at the absolute version of that series, and then if the absolute version converge, then the original thing that you're trying to investigate will also converge. If the absolute version happens to diverge, then you can't say anything about the original thing that you're trying to investigate. Okay, so for example, if you're trying to investigate this, if you're trying to investigate this, it's saying what you should do is you should look at the absolute version. The absolute version of this happens to be this, because all this is doing is that this thing here is making it plus 1, well, negative 1, plus 1, negative 1, plus 1. This is all, and so on, negative 1, plus 1, and so on. All this thing here is doing is alternating the sign. So it's saying that if you want to investigate this series, if you're trying to determine if this will converge or if this will diverge, it's saying you should look at the absolute version of this thing. Well, the absolute version of this thing is really you discarding this alternating sign. So the absolute version of this will be this. Now it's saying you should look at the absolute version. If the absolute version converge, then the thing that you're trying to investigate, the series that you're trying to investigate, will also converge. If the absolute version happens to diverge, then you can't say anything about the original series. Because the original, if this thing here diverge, then the original one could still converge, or it could diverge. So if this thing diverge, then you can't say anything about the original. But then if this thing here happens to converge, then you can immediately stop what you're doing and conclude that this thing will also converge. So that's what the theorem is saying. Now, let's now try and prove it. So if you have something that's alternating, so if you have this thing here that's alternating, you can so this thing here will be plus 1, negative 1, plus 1, negative 1, plus 1, negative 1, and so on. Well, if that's the case, then you can actually say 1 over n squared will always be, well, the biggest thing that this thing here could be is when it's 1. So you can say, you can trap it in between n squared. Well, the lowest thing that this thing here could be is when this block here is negative 1. When this block is negative 1. So negative 1 times this thing here. Well, the lowest thing would be this. So the negative version. So you can say that this thing here is always trapped in between the positive version and the negative version. Just because of this thing here, it's alternating. It's either minus 1, plus 1, minus 1, and so on. So if you have an alternating series, you can actually say this thing here is always trapped in between here and in between here. So now what you do is you add the absolute. You add absolute an. So this here will cancel out. So that will then give you 0, and then this is your so when you add the absolute an here, this will then become this, and then when you add for this one here, when you add another an, or when you add another absolute an, it becomes 2 an. Okay, so I will continue in the next video. I will elaborate more on this in the next video. Okay.